Hello guys, I welcome you all on this wonderful platform that is Byju's Exam Prep. And in this next episode of Concept Capsule, today we are going to discuss about the concept of core, kern or kernel. First of all, you must understand this is a topic related to strength of materials, column and strut topic. Okay, so guys, we will be having the discussion on this. You know, in this Concept Capsule series, we are taking the topics about which we are discussing, and these are those very important and interesting topics which are asked in interviews, which are asked in GATE exam, engineering services exam, ISRO, DRDO bar type of examination. So they are some very important wonderful concept of mechanical and civil engineering. So guys, now let us start without wasting the time. Those students who are watching me for the first time, this is some introduction about me. So my name is Dheeraj Sadana. I am having 10+ years of experience, have written many research and review paper, qualified many examinations, and these are my areas of expertise. So guys, without wasting your time, let us start the discussion on the topic. So my dear, the topic is concept of core or kernel. So my dear, whenever we are talking about core or kernel, what it is actually? My dear, actually, whenever we are talking about columns, so whenever loading is there in eccentric way, means if load is not passing through CG or centroid, then my dear, it would be creating a couple which will result into some tensile stresses. So my dear, whenever we are talking about the column, they are generally made up of brittle materials like concrete and all. So brittle materials are weak in tension. So my dear, we want to find out a region in which if eccentric loading is applied in the column, we would not be having any kind of tension in the column. So we are in search of that region, and that region of cross section is given the name of core or kern or kernel. So my dear, as you can see, this is defined as a part of cross section in which if an eccentric force is applied, will not create any tension in the column. So my dear, that I will be showing you with an example. Let us say I am having a column like this, and my dear, when I am having this column like this, let us say this is the cross section. Okay, so my dear, this is the cross section. Obviously cross section would be having some centroid or CG. So let us say this is CG or centroid. So my dear, if some force is acting at CG or centroid, then my dear, this force will not be creating any kind of tension because it is direct compressive forces. And if you want to find out the stresses because of this, then my dear, stresses because of this will be coming directly compressive like this. This type of stresses would be coming. Okay guys, so this kind of stresses would be coming like this. So this is sigma C will be minus P by A. Yes, it is sure. So this is the case, my dear, when this is direct compressive force passing through CG or centroid. Then my dear, what happen if I say that this force is becoming eccentric? Then what will happen? If I show you the column in this way, like this. So my dear, if we say that this force is acting at this position, it means it is somehow eccentric to CG or centroid. My dear, when it is going to be eccentric to CG or centroid, then if you will try to see the effect of this force at CG or centroid, what we will do? You can see there is zero force on the CG or centroid. So we will apply to equal and opposite forces, P and P, in such a way that net force at the centroid is still zero. And this P and this P are making a couple as they are to equal and opposite forces separated by a distance E. They are creating a couple like this. Oh, if you see this couple carefully, so my dear, this couple is coming downward on the left hand side, going upward on the right hand side. So it means it is creating compression in this part and tension in this part. So if I divide this column into two parts, in this part tension will be coming because of couple, and in this part compression will be coming because of couple, and we are left with this force and this couple. So if I show you the same on the next slide, we are left with this force and this couple. Okay, this is the case when force is applied here eccentric. Okay, so in my figure I have shown the force in the left hand side. Okay, let us take our case only. If I will be considering our case, this is the column, the things are going to be same only, and this is cross section. So you know that, my dear, if this is the force and this is the couple, let me show you in the previous slide where was the couple. Couple was like this only. So couple is like this. So my dear, you know that if I show the bending stress and normal stress distribution, so because of this P and because of this P into E, because of the P, my dear, we will be having direct compressive stresses. So because of P, we will be having direct compressive stresses like this. They are going to be P by A, compressive. And because of the couple, we will be having bending stresses. You can see here it is compression, here it is tension. So the stress distribution will be like this. Okay. So like this. Now my dear, if I show you this stress distribution carefully, and if you are capable of looking at it, my dear, just look at it. If we see the left hand side of the fiber, this is compressive, this is compressive. This is negative, this is negative. Negative plus negative will always be negative. So my dear, left hand side of this axis is always under compression. And if someone asks you the stresses coming, it is given as minus P by A, which is nothing but the stress coming because of forces, and minus M by Z, which is the formula of bending stress. Because my dear, why I am writing M by Z? Because my dear, we will be talking about the extreme case. Here the stress is going to be maximum. So my dear, at this maximum stress fiber, the compressive stress will be this. And as you can see, there are two negative quantities additions are there. It is always going to be negative only. But my dear, if you are talking about the right hand side of the fiber, then my dear, this is compressive, but this is tensile. So to right hand side, there are chances that the net stress can come as positive stress, which we don't want. Why? Because we don't want column to be under tension. So my dear, if we give the guarantee that in this extreme fiber when tension is maximum, because you know in bending outer fibers have maximum stress. If we can save this fiber, from getting tension, the entire column will never be in tension, because this is the fiber where tensile stress is maximum. So if this tensile stress is going to be nullified by this compressive, we will never be getting any tension in the column, my dear. So my dear, let us see the right hand side calculation. You will be writing that stress on the right hand side fiber as minus P by A plus M by Z. So my dear, you very well know that if this dimension is going to be B is the width, this dimension is going to be D, then ZNA will be BD. Okay, we have taken the force in this way. This is the couple and this axis is acting like neutral axis. So my dear, we will be having dB square by 6. This is the value of Z. Those kind of things we have seen in the bending topic, my dear. So we will be putting the value minus P. Area of cross section, my dear, if you will tell me this is B into D, so we will put the value here. It is minus P by BD plus P into E by, this is dB square by 6. And if you are saying that it should not be having any kind of tension, put it less than equals to 0. By putting it less than equals to 0, you will be getting E to be less than equals to B by 6. Eccentricity to be less than B by 6. This is coming, my dear, when we have taken the load to be eccentric. Load to be eccentric in this direction. If load is going to be eccentric in other direction, if load is coming E forward or E backward, we will also be doing the same calculation again. And when you will be doing again same calculation, this time you will get eccentricity to be less than equals to D by 6. So my dear, if you see the cross section carefully, this is the column, this is the axis, this is the axis. So my dear, this was B, this was D. So my dear, we were having this centroid with us. This was the centroid. So if you are saying we can go B by 6 in this way, B by 6 in this way. So this B by 6 eccentricity is allowed. This side also B by 6 will be allowed, because both the side the effect is going to be in the similar way. If we are going to take load in this direction or in that direction, the effect only will be like that, that whatever the stress is coming in right hand side, they will come to the left hand side for the different case. So my dear, if you see this is B by 6, this is B by 6. Similarly my dear, you will find out here D by 6, D by 6. So here you will find D by 6, D by 6. So my dear, if you see this, you need to take that region in which if eccentricity is provided to the load, it must not be coming in tension. Many people would be thinking, sir, this is B by 3 total, this is D by 3 total. But my dear, if you are going to take this rectangle as the core, kern or kernel, then there will be problem, because this is B by 6, this is D by 6. But if we go diagonally, this distance will be more than B by 6 and D by 6. So because of that, when we are going for core, kern or kernel for this case, what we choose is, if I show you the cross section, only, then my dear, I am telling you that this was B, this was D, and my dear, if you are going to choose like this and like this, so my dear, you will be finding out this. We will join this. So my dear, this is that region which is said to be core or kern or kernel. In this, anywhere you take your load, my dear, wherever you want, you take your load, and my dear, you will find there is no tension in the column. Okay, and my dear, as this is covering 1/3 part of width and 1/3 part of depth, that is why sometime it is also given the name of middle 1/3 rule. Why middle? Because it is using middle 1/3 part of the cross section. So sometime it is also known as middle 1/3 rule. Is it clear, guys? Yes. And the same kind of concept we can also have in case of the circular cross section. So that we have seen, this was the rectangular cross section. I am showing you again. So this distance was B by 3 and this distance was D by 3. This is core. The same if we see the circular section, my dear. When we are going to have circular section, as you know, circle is same from all the sides. If you see the circle, you can see from center all the points are at the same distance. So there is no problem like in rectangle we were having. So here whenever you are going to find out the core, kern or kernel in the same way like we have done, you will be getting this much portion which is going to be D by 8 distance from the center. D by 8 distance from the center. And as a total it will be D by 4. So it is said to be middle 1/4 rule. Middle 1/4 rule. Why middle 1/4 rule? Because D by 8 will become D by 4. So my dear, this is how we can find out those regions in which if we apply the direct compressive load, it will not be creating any kind of tension, and such kind of regions are given the name of core, kern or kernel. So guys, just like the session, share the session and subscribe the channel. Goodbye for this session, guys. We are going to meet soon in the next episode of Concept Capsule. Signing off for today. Goodbye.